Disclaimer. This video is not all about exponential functions. We are also going to go over linear and quadratic too. See you in the video. Welcome to part 3 of the exponential functions series. Now we are going to go over when a equals 1 in specific equations. We already went over exponential functions, which when a equals 1, it is just a straight line with zero slope. When you have a equals 1 on linear, you have an equation. You just have an equation with a slope of 1, which means it is a straight line that goes evenly across all the boxes on the graph, going through origin, all that stuff, if you have the base parent function with a equaling 1. With quadratic functions, it is just the parent function because, well, 1 times x is just x. You can't change that with a 1. Well, how are we going to factor these? First, we need to know what factoring actually is. Factoring is where you take factors out of the equation to make it simpler to understand and solve. Now, to be able to factor these equations, we are going to need some examples first. Here are some examples. Try to solve them before we get into how to solve them, if you can.
Let's solve the linear one first. To solve this one, we can't do much on simplifying and factoring. The one thing we can do is make that 1 invisible, as it is not necessary to be there. The reason we can't do anything else is because a is equal to 1. And to factor linear equations, a has to be something else other than 1, so we can factor it. And so we come to exponential. This is almost the same story, as that 1 can just disappear and become invisible, and 3 to the power of x minus 1 is the most simplified it can get, as we cannot factor it any further, as 3 and 1 don't share anything. And finally, we come to something we can factor. Quadratic. Now, when we factor this quadratic equation, first we will need to take out that 1 as usual, because it plays no role, it does not change the x squared. Then, we have negative 11x and plus 28. Then we can take a look at the factors of 28, which are 1 and 28, negative 1 and negative 28, 4 and 7, negative 4 and negative 7. Then we put those with negative 11, which ones added together make negative 11. It's negative 4 and negative 7. We can write that as so. Now that we know how to factor all the equations, and if you can actually factor some of them, depending on the circumstances, goodbye, see you next time, and I hope you've learned a lot from this, and maybe we'll have more of these in the future, who knows. See you guys next time. It's been Z, and goodbye.